Although New Zealand is known for its big mountains, beautiful beaches, lovely people, hobbits, and waterfalls, for Kirk, Schleiffarth, and I, it's all about the volcanoes. With Kirk flying in from Arizona and me from Western Australia, after arriving in Auckland, it's probably no surprise that our first stop was an ancient volcano. This is Kirk, PhD candidate extraordinaire at Northern Arizona University, brilliant igneous petrologist and volcanologist, and serious mountain climber. Kirk and I have been picking up rocks and climbing mountains together for over 10 years, and I was stoked for our adventure in New Zealand.
I'm here on Paku Hill on the east coast of the North Island of New Zealand. And Paku Hill appears to be remnants of an older volcano. The volcanic flows and deposits that we're standing on are all tilted here to the south, which suggests that this was part of a larger edifice in the past that's since been eroded away. And much of the North Island is really an amalgamation of older volcanoes. And we can see remnants of other volcanoes off the coast here. And all of these islands are former volcanoes that have eroded away and are now these isolated little islands.
While the ancient volcanoes along the eastern coast were spectacular, Kirk and I were hoping to find something a bit more active. So we continued our drive south to the town of Rotorua, where volcanic features are everywhere, and smack dab in the town's central park.
I'm in the heart of Rotorua, one of the major cities in the southern part of the North Island, in a major volcanic zone. As you can see, I'm surrounded by several geothermal features, such as hot springs and fumaroles. You can see the steam venting. And although it's winter here, you can feel the warmth of the springs surrounding me. You may wonder, why are there hot springs here in the middle of this city? Hot springs require there to be a low water table, so there needs to be water close to the surface. There needs to be a heat source, and there must be a way for this heat to reach the surface through maybe fractures or faults. The fact that there's so much heat here in geothermal activity implies that the heat source or magma bodies are very shallow beneath the surface. This magma is probably related to the subduction zone off the coast of New Zealand. The Pacific Plate is currently subducting beneath New Zealand. As this oceanic crust dives through the mantle, it drives melting, and this magma reaches the crust and rises through fractures and faults here in the Taupo volcanic zone.
Evidence of geothermal activity is plentiful in the region around Rotorua. While many complain about the smell of sulfur, we have learned to love it, only because it means the magma is not very far beneath our feet. And despite the threat of impending doom from volcanic eruptions, the Kiwis have made the best of the situation by harnessing the geothermal power to generate electricity.
We're at the Wairake Geothermal Field. This is a large steam field in the Taupo volcanic zone. Over 60 wells are producing steam. This steam travels through these pipes that you can see at speeds of 200 kilometers per hour to a power plant where it produces electricity for much of the North Island.
Alright, Kirk. Geothermal energy is cool and all, but we didn't come to New Zealand for mud pots and steam vents. We came for volcanoes.
I'm here in Tongariro National Park, which is the most active region of the Taupo volcanic zone. Behind me, we have Ngauruhoe and Tongariro volcanoes. Both of these volcanoes have been active in recent times, and most recently, Tongariro erupted in 2012. Tongariro National Park is one of the more popular regions to visit in the North Island. It's a large preserved area of volcanic features where tourists can come and hike and see volcanic features firsthand. One of the most popular hikes in the region is the Tongariro Alpine Crossing, which crosses in between these two volcanoes. Along this hike you can see steam vents and volcanic lakes, fumaroles, and a variety of fresh volcanic deposits. Tomorrow we'll be hiking across the Tongariro Crossing and getting up and close and personal with all of these volcanic features.
After a quick slog to our hut, some gross dehydrated macaroni and cheese, and a good night's sleep, We were up early to conquer some volcanoes.
So it's about 6:30 in the morning. We had a good night's sleep at the Magnete Popo hut, and we're now just on our way up the Tongariro Alpine Crossing. We will summit today the Ngauruhoe, is that how you say it?
Ngauruhoe.
Ngauruhoe, and then also up to Mount Tongariro, both active volcanoes. Tongariro. Thank you.
We reached the saddle at sunrise, only to see the tremendous hike that lay before us. It was only a few kilometers, but ankle-deep scoria sitting at the angle of repose made it slightly more difficult than your average walk in the park.
So we're here on the top of Ngauruhoe volcano, here in the Taupo volcanic zone. If we look kind of to the northeast, we see the chain of volcanoes that are part of this subduction zone. This just happens to be one of those volcanoes, and this volcano shows lots of evidence of recent activity. We've got fumaroles here on this flake. You can see that the snow has melted off due to the hot steam that's being emitted from the inside of this volcano. These fumaroles are often just rainwater that trickles down through the volcano and then are reheated and flashed to steam as they approach hot rock. And this steam rises to the surface and is emitted across the summit crater here. This is an amazing crater, seriously. This is a small crater that formed in 1974, and it's a small crater within a larger crater. This one's really well preserved. You can kind of see the layers in the crater walls. It's been covered with snow. We've got these active fumaroles all around us. This is a really awesome place. So volcanoes are dangerous even if they're not erupting or active. While this volcano is dormant, could erupt again. The most dangerous thing about this volcano today is the slopes, the unstable slopes. So as groundwater circulates through the volcano, these hot waters can alter the minerals of the fresh volcanic rocks. And eventually, if it undergoes enough alteration, if you look closely, it can turn to clay. This significantly weakens the slopes and allows slopes to slide and fail. It can cause major landslides, big volcanic mud flows known as lahars, and can kill things in its path without any warning. In 2012, Tongariro had an explosive eruption. This eruption lasted for several months, and eventually there was one slope that failed and caused a very devastating lahar. This lahar traveled for several kilometers down the slope and almost crossed a major highway. So my studies will be using geochemical data from these altered slopes and relating it to satellite imagery to see if we can find a correlation. And that way we can use satellite imagery across the world to predict whether volcanic slopes are likely to fail or not. As you can see, these slopes aren't very stable already. Lots of loose tephra and rocks on these slopes slide very easily. However, what we're most worried about is when the bedrock, the solid rocks, become so altered they can slide as a single unit and transition into a lahar down the slope.
Once we made it down from Ngauruhoe, we climbed over the Alpine Crossing and had spectacular views of recent lava flows and volcanic acid lakes. Eventually, we made our way to the top of Mount Tongariro. While some could say this excursion was simply mixing business with pleasure, our time on the steep slopes of these dormant yet hazardous volcanoes provided important insight into how the weathering process of volcanoes can lead to catastrophic slope failures.